Hello and welcome to another episode of the Geotechnical Engineering Podcast, a podcast focused on helping geotechnical engineers stay up to date with technical trends in the field. I'm your host, Jared Green, and I've practiced as a geotechnical engineer for over 18 years. And in addition to practicing engineering, I enjoy mentoring young engineers and first-generation college students. I've focused on helping to increase the number of pre-college students that are interested in STEAM majors and fields. By STEAM, I mean science, technology, engineering, art, and mathematics. In this episode of the Geotechnical Engineering Podcast, I'll be talking to Ms. Cassandra Wetzel, the District Office Manager and Principal at GZA GeoEnvironmental Incorporated, about design and construction around the water table. As GZA's District Office Manager and Associate Principal, Cassandra's focus is to go beyond traditional solutions, combining geotechnical and environmental engineering expertise to design and implement complete multidisciplinary solutions in the architecture and engineering, contracting, and energy client sectors. Serving clients across New England and the Mid-Atlantic, she has played key roles in the design and construction of many marine, highway structure, commercial development, urban building, and power projects. As an experienced geotechnical engineer with the breadth and depth of knowledge to handle any challenge in our natural or in built environment, Cassandra will work with you to identify and deploy a multifaceted, cost-effective solution that will meet your wide range of environmental and construction needs. And with that, let's jump right into our conversation with Cassandra. Cassandra, welcome to the Geotechnical Engineering Podcast. How are you doing?
I'm good, Jared. Nice to be here. Thank you for inviting me.
Awesome. Really glad that you can be here with us, and pretty excited that we're really focusing in on this topic of the groundwater and the water table. When I think about geotechnical engineering and really the fundamentals of what it means to deal with soil as a particulate matter, it's like the water table is something that sometimes it's so fundamental that sometimes we don't think about it. So I'm glad we're going to really focus in on that.
Yes, absolutely. I mean, as you said, we're mostly focused on the soils or the overburdened soils or bedrock itself, and water table seems to be a side note. And oftentimes it isn't a side note. It is sometimes the primary design driver.
Exactly. So for some of our listeners that, let's say, they're not too familiar with water table design, how would you explain what is the water table? Like, what are we talking about when we hear water table? What's that all about?
Well, water table is actually the elevation at which a stabilized water body is encountered below the ground surface. So water below the ground surface is always trying to get to a point where it's at atmospheric pressure. So it's always trying to go to elevation zero. And then sometimes it's prevented from getting to elevation zero by barriers within the subsurface stratification. So it's wherever we find stabilized water level. So regardless of what elevation you're working at, it's some depth below the ground surface where you know you're going to be encountering stabilized water. Now, across a particular site, that water table could vary, in which case we have what's known as a hydraulic gradient. So that water table is actually a moving surface. Some people refer to them as underground streams, but that water table is actually moving, and it can be moving at a different rate of speed, and that can affect your design. So that's something we're always looking for.
Okay, excellent. And when we talk about the water table, I mean, there's a lot of considerations that need to be made, saying during design or during construction, but what are some of those considerations?
Oh, that's a good question. So depending upon where your ground surface is, where the elevation of the groundwater table is encountered, the considerations you want to look for is it a hydraulic gradient? Is it a stabilized groundwater table? Or is it something that's just localized and perched above a bedrock or a clay layer? Is it something that is well below the proposed construction work and will never be encountered by the contractor during construction? It's so important to understand if you are going to be encountering that groundwater during construction. So During design, you want to ask questions. You want to understand what's proposed by the structural engineer and by the ownership. The groundwater table can change throughout the year. It can change several feet. It can change, over 10 feet in the course of a 12-month period. So understanding those variants as far as what can be impacting not only your engineering characteristics of your subsurface conditions and your unit weights, but also, are you designing a basement that's going to be encountering that groundwater surface and need to account for buoyancy forces acting on the floors? Or are you going to have water seeping into a subsurface structure, a basement, for example, and you want people to be using that space? Those considerations are important because if you are going to be excavating within bedrock, for example, you could be collecting groundwater, and you have to be prepared to make recommendations to get rid of that water and to keep your structure dry and to avoid those hydrostatic pressures.
Got it. So there's a lot to think about there, a lot to think about.
Yeah.
So I guess the $1 million question is, how do you know where the groundwater level is? Like, how do you know that?
Oh, no, good question. Also, the way we determine where the groundwater surface is through a series of soil borings, test pits, and the installation usually of temporary and or permanent observation wells. The wells will extend to a depth below the elevation where we believe the groundwater table exists. And then measurements are taken over a period of time. The period of time could be during the exploration program, or it could be over a period of a year, in order to understand the fluctuation in that groundwater surface. Yeah, the series of wells, but it's important to understand your current elevation of your site compared to the proposed elevations and grading of your site, and where you believe that water table is, so you can determine if the water table changes over across your site in any way. You could put a well in on accident that's too short and actually doesn't interface the water surface, and then you're not collecting the information you need for design or for construction. Other times you could understand very well where the groundwater surface is, but you could be within a flood zone, and you could be in an area where that groundwater surface could rise, and not only rise during seasonal changes, but rise because of a flood or a storm event. And that could have incredible challenges during both design and construction that the geotechnical engineer has to draw attention to when we're providing those recommendations for not only design, but for construction. The contractor is going to be dealing with the water table throughout the construction of the foundations or any excavations. And so the geotechnical engineer is responsible for identifying those considerations and pointing out the construction risks that they could be facing.
It's a lot to think about. And, when you say that the groundwater fluctuates, I think that that's something that we have to make sure that we get our hands around, because if the groundwater fluctuates, you said 10 foot, right? If it can fluctuate 10 foot, like if you're in a flood area or something like that, if that's not accounted for, you're going to have a problem one day, right? It might not be in the first year of construction, but it could be when the flood event happens. So what are some of the things we need to be making sure of? This is probably before the exploration, making sure that we're installing wells. How many wells should we install? Of course, it depends on the site, I can imagine. What depth we're installing the well to. These are things that we need to think about before we go out and start drilling.
Yes, and then also checking your firm maps to determine if you're in that flood zone. Another consideration, while we might not necessarily call it groundwater, when you work in an urban environment like we do, there's always the possibility that you could be encountering water that's induced onto a property from a utility, a broken utility, and you need to be prepared for that as well. So if there's a water main break or some flood from some other incident, then that can impact you, your construction and your design. So you want to be prepared to make recommendations for that. When we look at the water and the saturation levels of soils on project sites, as geotechnical engineers, we're always looking at particle size, plasticity, fee angles, unit weights, but the water table itself and how it impacts construction and the workability of the soils can have an incredibly strong impact on the construction means and methods, the seasons at which the contractor is recommended to work in order to get the soils to their optimum compaction levels. That can have a significant impact on the contractor's anticipated completion, when they can work, or if they have to take mitigating measures like dewatering systems, or treatment of the soils beforehand, regrading of the soils to increase the granular nature of the soils if they happen to be very fine grained. So these are things the geotechnical engineer needs to be considering on the construction side, not just design. So that's where, you know, we have to wear a couple of different hats when we're looking to make recommendations for both design and construction.
Yeah, you're absolutely right. I think one of the tricky things is if you have, let's say, shallow foundations that are going to sit on soil and it's a moisture sensitive soil, you could approve the subgrade today and it doesn't get covered, doesn't get protected. It rained. Now all of a sudden it's no longer approved. And that's always a very difficult conversation to have if you haven't had it on the front end, right?
Exactly. Exactly. And those soils, while in dry or arid environments or dry or arid months, they could be proof rolled and compacted and exceed our expectations. But once you have a rainy event or you're working through the rainy season, as soon as the contractor even begins to touch them, they become completely unworkable soils. And they're detrimental. And the excavation language we sometimes say is go ahead and remove the disturbed soils. Well, that could be infinite if they continue to attempt to work them in a saturated case. So oftentimes the geotechnical engineer and inspectors are asking the contractor to please wait or to please stop work until the soils have a chance to dry out. And that's not always the most popular recommendation. But it's a really sometimes your only alternative if you're dealing with a large property or disposal restrictions for dewatering or potentially contaminated sites. So you got to look at all of those cases.
Got it. And I guess you never want to recommend that something can't be done. So we have to figure out a way to do it. So if you want to put a foundation in and you're going to have to work with soil or bedrock that's at the water table, what are some of the, I won't say tricks of the trade, but what are some of those things that we have to keep in mind?
Yeah, no, that's it. That's coming up with those solutions and making recommendations. Obviously, we're not going to be able to control the contractor, but working in dry conditions, you might need to lime treat or lime stabilize soils in order to reduce moisture content. You might need to put in a gravel subbase, a workable gravel subgrade that stabilizes the soils at least for 6 inches to a foot or so. That creates a stable surface, at least for the short term, and allow the contractor to put in reinforcing steel and get the concrete poured in dry cases. Or a dewatering program, putting in well pumps and well points in order to get that water out. Oftentimes, a sump is acceptable to collect localized water during a rain event or in a small excavation. But under a large site where you really need to pull the water table down, well points are a great option. In an urban environment, you know, well points can be detrimental to your neighbors. So you definitely want to take that into account, as well as settlement within the radius of influence when you're pulling down the water table. So the water table, again, it has such a strong influence on the geotechnical engineer's recommendations and the design solutions that we come up with. We have to really consider the larger impact to what we're recommending.
Excellent. And what would you say, you know, the duration of observing the groundwater? I mean, I can think of projects where we observed the groundwater for 3 days. I can think of some where we, you know, observed it for 12 months. But what would you say for a range and what's appropriate and how do you make that determination?
I think that's a really great question. I think it depends on the project. I think it also depends on how close you believe that groundwater level or the phreatic surface is relative to your proposed design. If you believe you're within a couple feet, And if that groundwater elevation should change, then the structural engineer would have to redesign slabs to withstand buoyancy forces. It's worth taking the extra readings, and it's worth making some extra visits out to the site, and having a conservative elevation for design. You might measure during your geotechnical exploration a certain elevation at which the groundwater was encountered, but you might be out there in the middle of summer when it's very dry.
Yeah.
So you're definitely you're gonna have to go back out there and take another reading, or at least alert the design team that this is likely at a lower level than what can be anticipated during the winter months.
Makes sense. Makes sense. Thank you for that. And we have a lot of younger listeners that tune in, so I think that with this one they'll appreciate this question. But overall, the geotechnical engineer, what do they need to review? What do they need to identify? What do they need to consider when they're thinking about groundwater and they're making recommendations?
Well, for a junior engineer, like I've stated, is that the water table has a lot of different impacts on what we're recommending on a design standpoint, right? So it has a change in the unit weight, has a change in the pore water pressures acting on retaining walls. It has an influence on the potential for flood and resisting that, and keeping the future spaces, the future structures dry. And so it's important to understand, what I've found is important to not only understand the risks associated with water levels changing, both during design and construction, but also understanding how your soils will behave. So understanding the granular nature and the sensitivity that the soils will have when exposed to a saturated state. So when some soils, fine grained sand, when it's saturated, it just becomes running sands, and contractor can excavate one bucket full of soil, and just like when you're at the beach, it just fills right back in, and that will undermine surrounding foundations. That can be a very large risk. And they don't realize what they're doing because they feel like they're just taking one bucket out at a time, but that bucket is, the soils are running in from your surrounding areas. That's a big risk.
Yeah.
The other thing we mentioned earlier, which was the sensitivity of moisture sensitive soils, which contractors don't always have a firm handle on how sensitive they are and how unworkable they are. And they're looking for your input. So if you can do the right laboratory testing early on during the exploration phase, you're going to have more information during construction to help them solve those problems.
Makes a lot of sense. Makes a lot of sense. Getting that information early on makes everybody smarter when you get to the point where you're bidding on the actual solutions, right? Because if one person has to assume one thing, another person has to assume another thing, that's how you have the spread. So
run a couple of extra lab tests. It can't hurt. Exactly.
Can't hurt. Can't hurt. No. And Cassandra, what options are available for, let's say a client says they want to put in a subterranean space and they're close to groundwater? What options do they have for construction? That could be for, supportive excavation. It could be for, mitigation against water infiltration. What kind of things should they be thinking about?
Well, there certainly are a lot of ways to keep the groundwater table at bay. That requires some sophisticated engineering to create essentially a cutoff wall.
Okay.
These are usually constructed of concrete and steel in order to withstand the soil load and the water pressures. But they can be created such that they cut off the water table and will allow you to build in a dry space, essentially creating a bathtub environment.
Okay.
So the engineers study how deep and how strong those walls need to be designed in order to keep that space dry. There are also a lot of products that can be incorporated into the design to keep the water table separated from your concrete structure. So there are waterproofing options in order to keep your cellar and basement spaces dry. And then as a third mitigating measure, if you have water in your basement after construction, you can always install things like French drains or deep sumps or secondary pumping systems that require electricity and pumps to run in order to keep that water out of your space. So there are a lot of different options that you could consider.
Excellent. Excellent. And I guess you could also raise the building, but we don't want to offer that.
Nope.
It's like, got to make it higher. All right, cool, cool. And what advice would you provide to our listeners that they might be, trying to think if they should go mechanical engineering or civil engineering, and they land in civil and they say, should I be a geotech? Why would you suggest that they consider a career in geotechnical engineering?
Question. I tried out a lot of different civil fields actually when I was in college. I had a lot of internships myself, and geotech was my last one and my absolute favorite.
Nice.
Despite the heat in the Central Valley of California, geotechnical engineering is a hands-on engineering, and it is an engineering field that allows you to see so many different types of projects and have so many different types of challenges, both from design and construction perspective. I think what I enjoyed the most about it is that while you are trained and educated to understand the geotechnical aspects of a particular project, as you begin to work on your projects, what's driving your design sometimes are things that are out of your control. They could be the neighbors, they could be the owner's schedule, it could be a lot of things that are outside what you find during your subsurface exploration. So I find that that's always really, really fascinating. And I also feel like as a geotechnical engineer, you have the opportunity to work in heavy civil construction environment and get out in the field and see what you designed come to life. And that is really, I believe, one of the best benefits of being a geotechnical engineer. Yeah. I also feel like as a geotechnical engineer, you have lots of tools in your tool belt. So you just never know when your training, your education, your project experience is going to come back to help you and help your clients and help your owners have a successful project.
That's awesome. Well, if I wasn't a geotech, I'd want to go into a geotech after hearing that. Well, that's a good note to pause on. We're going to come back in just a moment and close this one out with Cassandra on our career factors, safety in segment. Stick around. All right, welcome back. It's time for our career factor safety in segment. In geotechnical engineering, just like many disciplines of engineering, it's important to incorporate a factor of safety into your design. But what about incorporating a factor of safety into your career? Today, we're here speaking with Cassandra Wetzel. Cassandra, with your current role as office manager, how do you engage your team members to be successful, and how do you lead them to develop their own potential? Can you tell us how you manage this and give you also a factor of safety against unproductivity?
Good question, Jared, really. Well, our company truly encourages continuing education and encourages personal ownership of your career and your future. Now, that being said, we're all being asked to read a white paper or participate in after hours events or go to a lunch meeting, or we have internal training as well. Now, that's always a balance between how many hours are you going to be spending doing that versus how many hours are you spending doing your technical work and your actual project work. But because of our annual review process, we really look at the longer term goals of individuals and where they're trying to get to next. So oftentimes we're saying to ourselves and to them, which is, have you had a chance to review your goals, and the additional training you're asking to participate in, or I'm asking you to participate in, does that fit with your goals and with your long-term objectives? Now, career development, obviously, it's a journey, and so you do have to be responsible. So we do ask not only that GZA and my company is committed to giving you time and resources in order to advance your career, but we also ask individuals to give time of their own, to do some additional reading, to read up on leadership, or to read a book on their own time, or even to attend a function after hours on their own time. Now, the company might pay for the attendance, but it's your own time and it's not being compensated during normal work hours.
Got it.
So there's sort of that balance, and that's how we manage it in our office.
Awesome. Thank you so much. Cassandra, thank you for coming on, and thank you for sharing all the great insights that you did with us. You shared a lot of information. I'm sure that the advice you shared is going to be very valuable to our listeners. If there's a listener that wants to learn a little bit more, what's the best way for them to reach out to you? Social media or email you want to share?
Well, absolutely. So you can always reach out to me on my LinkedIn page. So I've got a LinkedIn account with Cassandra Wetzel at GZA. And then my email address is Cassandra, my first name, period, my last name, Wetzel at gza.com. But I'd be happy to answer any questions, or happy to be a resource. With engineering and with career development, it's a constant case of learning, a constant opportunity to learn something new. And I say this to my junior staff and even to other engineers at my level who are looking to get to that next place in their career, is that, every project, every opportunity you're faced with when you're going through your regular work week, you have an opportunity to learn something. And it might not always be technical in nature. I always feel like you can learn something with regards to interpersonal skills, business development, marketing, money management, so many areas where there are other people that are very, very skilled at it. So you need to stay humble, look for those little nuggets of information and learning, and just enjoy what you do.
Excellent. Thank you so much. That was great.
You're very welcome. My pleasure.
I hope you enjoyed the episode today. We would love to have your feedback, comments, and/or questions. Please feel free to go to geotechnicalengineeringpodcast.com, where you'll find a summary of the key points discussed in today's episode, that being episode 17, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, we wish you the very best in all your geotechnical engineering endeavors. Peace.